Hi guys, Dr. Justin Southey here, looking at semester test 2. We're doing question 5, where you're asked to calculate the following limits without using L'Hopital's rule. So question 5.1, you're asked to find the limit as x approaches 0 of x squared minus x all over x. Now of course you can take a common factor of x out of the numerator and then cancel it with the x over here. You can do that because we don't care what happens at x is equal to 0, so you can divide top and bottom by x without fear of dividing by 0. So this is equal to the limit as x approaches 0 of simply x minus 1. These two expressions are equal at every point except 0, of course. And this now is a nice continuous function. You can simply substitute the x into there, and you get the limit as x approaches 0, put 0 in there, and you're just left with minus 1. So that was a nice, easy question. Okay, 5.2 is a little bit more interesting. You were asked to find the limit as x approaches infinity of x minus the square root of x squared minus 3. And of course, x is approaching infinity, and x squared minus 3 square root is also approaching infinity, so you end up with infinity minus infinity, which is one of these indeterminate forms. We've got a very useful trick to deal with this. We simply multiply by 1, but we multiply by a very special version of 1. We multiply by the conjugate divided by the conjugate. So this is equal to x minus the square root of x squared minus 3 all over 1 multiplied by x plus the square root of x squared minus 3 over x plus the square root of x squared minus 3. So we're just multiplying by 1 over here. So this is equal to the limit as x approaches infinity. When we multiply the numerators together, we get x squared. The middle term disappears because x times the square root minus x times the square root disappears, and we're just left with minus the square root squared, which just leaves us with x squared minus 3 in a bracket over there, and that's divided by x plus the square root of x squared minus 3. Now you can see that there's some terms that can cancel. We've got an x squared here, we've got a minus x squared, so we're just left with minus 3 is 3 on the top, divided by x plus x squared minus 3. Now, x is approaching infinity, x squared is approaching infinity. If you subtract 3, well, that's not really going to get much smaller, so this thing is approaching infinity, the square root of that is approaching infinity, infinity plus infinity, the denominator is very much approaching infinity, the numerator is simply a constant, and the constant divided by something that's approaching infinity, of course, is equal to 0.